Hello, my name is Hassan Zarze. Welcome to the third video of my calculus lecture series. Now I'm gonna talk about when do limits not exist. So let me give a definition here. If there exists no, so we already know the definitions of limits from my previous videos. If there exists no L such that limit x goes to a fx is equal to L, then we say that limit x goes to a of x does not exist. So this is pretty straightforward. So, and in this video I'm gonna give a couple of examples where you cannot find any value as the limit of a function. My first example is the sine function, which is also known as the Signum function, near x is equal to 0. And that function is, for those who don't know, sine x is equal to -1 for x negative, 0 for x is equal to 0, and it is +1 for positive values of x. So if we plot this function, it is going to be something like this. For positive values, we have +1. For negative values, we have -1. And for 0, we have 0. So, although we have the Signum function defined at x is equal to 0, the limit is not defined, because if you write down the right limit and the left limit, we see that they're different from each other. So if you write the right limit, if we approach from the right hand side to x is equal to 0, then we approach +1 because it's a constant function for positive x values. If you write down the left limit, if we follow this constant line, we approach to -1. So the limit from the left hand side is -1. So the limits from the right hand side is not equal to the limit from the left hand side, and that's sufficient for us to say that the limit does not exist. Another example is sine of reciprocal of x. It's like this: limit x goes to 0, sine pi over x, for example, or 1 over x. So this limit does not exist either, because as x approaches 0, pi divided by x becomes larger and larger, and the value of the sine pi divided by x is gonna be between -1 and +1, but we are not gonna get close to any specific value, which means that this limit does not exist. If we write this on a if we plot this as a graph, it's gonna look like this. Let's say this is +1, this is -1, this is going to be a periodic function for large values. The frequency is going to be small. For small values, it's going to get more and more frequent, but it's always going to go back and forth between plus and minus 1. This is x, this is y, and similarly for the and the repetition is going to be more and more frequent as you go as you get close to 0. So this value is not getting close to any specific value, but it's actually scanning through the entire interval between plus and minus 1, which means that this limit does not exist. Another example is the reciprocal of x. Limit x goes to 0, 1 over x. So this one as well will not get close to any particular value as x goes to 0, because as x goes to 0, this is going to be a larger and larger value, and you are not going to, every time you say that I'm getting close to some value, then if you decrease x further and further, then you can even go beyond that value, and this doesn't have a limit. Another reason is that if we get close to 0 from the right hand side, then this is gonna 1 over x is gonna get large and large positive values. 1 over x is gonna get 1 over x gets arbitrarily large values. On the other hand, if we approach 0 from the left hand side, then 1 over x gets arbitrarily small. In other words, negative values, which means that we get different values when we approach from the right hand side or when we approach from the left hand side, which is sufficient to show that this limit does not exist. An example 4 is limit x goes to infinity x. This does not exist either, because the value of x does not get close to any particular value. Yeah, every time you get a larger value, you go beyond any values. So, which means that this limit does not exist. Example 5. For example, limit as x goes to infinity sine x. This limit does not exist either, because this function periodically is going to oscillate between plus and minus 1, but it's not going to get close to any particular value specifically, because the function is gonna be like this. And so on. And this limit does not exist because it's gonna scan over all the values between the interval +1 and -1, and there is no special value that this curve gets close to. So we can say that this limit does not exist. So this is the end of this video. Thank you very much for listening to me, and in my next video I'm planning to talk about limits and inequalities, and I'm gonna give a couple of very useful theorems and their proofs, and hope to meet you in next video. Thank you very much.